At the beginning of all of my chemistry classes, I like to take a moment to talk about like how we actually communicate science. I think this helps us read textbooks and it reads articles in a way that's easier for us, but also it gives us I think, tools that we need to actually communicate our ideas in all walks of our life, but also as we try to put ideas together in laboratory experiments and try to draw conclusions and apply and synthesize what we're learning about. And so I'm going to take some time now to talk about communicating science, which is really, in my opinion, just about communicating evidence. And that's kind of the point of science, is that everything that we're saying has evidence to back it up, or support, right? And so it's critical that when you're expressing an idea, you're also providing evidence to support that idea and explaining how that evidence connects to the opinion that you're stating or the claim that you're making. So let's start by just talking about evidence in general, and then we're going to kind of go into how to communicate and how to kind of critique it as well. So in terms of evidence, I think of evidence as supplying an idea about scientific certainty. And scientific certainty kind of breaks up into three different elements here. And that's the amount of evidence that you have, the strength of the evidence, and the objectivity of the evidence. You take all three of those together and it kind of gives you a sense of how certain you are. And so for when we talk about the amount of evidence, it's really just like, literally, how much of it is there? Is it a lot? Is it just a little bit? Like, did I go just talk to two people down the street in my neighborhood to get an idea about, to support an idea that's a generalization about everyone in the world? That wouldn't be very much, right? Strength is really about having multiple lines of evidence instead of just one, right? Like you've got a couple of pieces of evidence that support an idea rather than just a singular thing. And so when I think about strength, I think about multiple lines of evidence. But also how well that evidence actually relates to the claim that's being made as well. And so sometimes you'll like a common thing to hear is like a statement being made and evidence given, but like the two really don't have anything to do with each other. So I think both of those contribute to the strength of the evidence. Also, we could talk about like how well designed an experiment is. Does it have any loopholes in it? Did they forget to account for something? Is there a control? And we won't go into a lot of depth on like what it is that makes a strong or weak study, or like how to design a really strong set of experiments to support an idea. It's kind of a higher numbered course. But these are three things that contribute to our general assessment of the strength of evidence. And then lastly, objectivity. And so one of the things that's really key in communicating science is also communicating how certain you are or uncertain you are about your results. And so being extremely transparent with your certainty or your uncertainty. Also, peer review, that others have reviewed your work and that it's reproducible and that you're open to review by others. And that's part of also being open to collaborating within the scientific community. It's kind of like a key part of making science happen and something being scientific. And so these are all considerations. And honestly, as you think about each one, they really are like a spectrum. And I really like this graphic right here because it shows them as kind of like, I guess, thermometers, right? Like it's like a temperature gauge on all of these, the amount of evidence, the strength of evidence, and the objectivity. And evidence can sometimes kind of fall where it's like very little evidence, but it's, very strong and very objective, or it's kind of all over the place. So let's kind of go through this with an example, and I think that might be helpful. So here is our different bars or ranges for each of our three things that we're going to evaluate. And we're going to look at an example of delta 8, which is different than like our normal idea of THC, which is delta 9, but delta 8 is a variant of THC. So when drops orally administered drops of delta 8 THC are given both before and after chemotherapy treatments, they can prevent nausea in pediatric patients. There's actually we've got this study here. I've given the citation for it, but I've pulled out an excerpt and I've highlighted a few things. So this is coming from the abstract of the journal article. So they go into a lot more detail following it. But basically, and these are in pediatric patients aged 3 to 13, they were given a dosage of 18 milligrams per meter squared as an edible oil. And so that's really talking about the volume of the child when we say meters squared. And so they're giving these drops. And the study did this to 8 children. They tracked 8 children that were going through chemotherapy. And they did this over 8 months, and they did something like 480 of these delta 8 THC oil drop treatments for the kids undergoing chemotherapy. And they give the range of times that they used the drops, and they were able to show that in all 8 patients, vomiting was completely prevented. So there was no vomiting associated with the chemotherapy in these 8 kids. And they saw very negligible side effects. They did say in the 2 youngest participants were the 2 that had some irritability and side effects. They were like 3 and 4. But the older kids did not have any negative side effects or of the psychotropic nature of the THC. So let's break this down. Let's first look at the amount of evidence. So we are looking at a case where we are looking at 8 kids being studied over 8 months. And again, it's something like 480 treatments. So the 480 treatments seems like a lot, but we're looking at a study of just 8 people out of the so many or 8 children. And so it's not one observation, but I think it's definitely not overwhelming either. And it doesn't compare to a control study. Well, we'll talk about that next. So I would put this on the lower end, somewhere around here, for the amount of evidence that was generated in this particular study. Now, the strength of the evidence, it's looking at, does it have like those multiple lines of evidence? How well designed was the experiment? How closely connected is the evidence to the claim? And I would say that there's a close connection between the two. Like absolutely no vomiting is preventing nausea in a treatment that usually causes it. There isn't multiple lines of evidence because we're just observing the behavior of the patients. So it's one line of reasoning. And then in terms of loopholes, there isn't, especially here in the beginning, a lot of talk about looking at what was the control that was done, or was there a placebo provided to another set of patients to compare? And so it has some loopholes in it, or it has some holes in the experimental design. And so the strength of the evidence is going to kind of be down here. So it's not like a classroom experiment, but it's definitely has some design flaws in it, or it's more not flaws, it's just lacking. And, it's probably challenging to get a large enough sample of children under the age of 13 that are going through chemotherapy that can participate in a study. So to be fair. Now, in terms of objectivity, for this, it's published, this article was published in Life Sciences. It's a peer-reviewed journal, part of the kind of mainstream scientific community. It was available for people to review, but to ask questions and try to reproduce results. And so I would put that up in the objective end of things. This isn't like a blog post, right, where no one's allowed to leave a comment. So as you can see here, we're kind of on the lower end for the amount and the strength, but it seems fairly objective. And so this doesn't really tell us if this is like good or bad research or science. It's just helping us understand exactly the level of uncertainty here and how much maybe weight to give this in decision making, which would be different for everybody. And so it's not coming with a label of good and bad, right? It's just making sure that it's really clear, like how strong this argument is, like, or how strong the evidence is. And it could be stronger, of course, but it could be weaker. And so it's kind of having your eyes open there.